Welcome to our session on probability, introduction to probability. In this chapter, we are going to explore the different concepts that are imbued in this topic called probability, being the measurement of uncertainty. So probability in statistics, we are looking at the chances or likelihood of events occurring. So we're going to dominate in looking at the theorems that are imbued in this topic and also the formulas that we need to know. So in this chapter, we'll look at the basics of probability. We'll define what a sample space is. We need to know what outcomes are and what events are. So as we progress, we'll look at the rules of addition and multiplication, as well as what is called Bayes' theorem. So these are key in probability. So to start with, probability has a few basics that you need to know. Every day we experience chances or acts of probability. For instance, the likelihood of a thief breaking into a house or having an accident or contracting a particular disease, all these are issues of probability. Now, there's what we call a sample space. A sample space simply consists of all possible outcomes that you may have. For instance, if you're going to roll a dice, you know what a dice is? You played the dice before. So a die has 6 sides. Looks something like this. Here we have a dot, 1, here we have a dot, 2, here we have a dot, 3. So if we're going to roll a die, the particular sample space will consist of numbers 1, 2, 3, 4, 5, and 6. So the chances of having a side, so this is what we call a sample space. The chances that we are going to have an even number. How many even numbers do we have? We have 2, we have 4, and we have what? 6. This is an even number. So what is the chance that when we roll a die, we'll get an even number? We use a formula, the number of possible outcomes over the total outcomes in a sample space. So there are 3 even numbers. We're going to put 3 over how many outcomes do we have? A die has 6 sides, 6. So the probability of an even number is 3 over 6, which is equal to what? Half, or 0.5. So this is one of the rules in probability that you need to know. Suppose they ask you to find the chances of an odd number. We have how many odd numbers? 1, 2, and 3. So the chances of getting an odd number is also 3 out of 6, which is half, or 0.5. How many chances do we have of getting a prime number? Which ones are prime numbers? Numbers that are only divisible by 1 and itself. So we have prime number 1, 3 is also a prime number, and 5 is also a prime number. So we have 3 out of 6, which is 0.5. Numbers more than 4. How many numbers are more than 4? 5 and 6. So we have 2 out of 6, which is 1 over 3. All right. So this is what probability really is all about. Sometimes you'll be asked, you have a deck of cards. A deck of cards has 52, where we have 13 diamonds, 13 clubs, 13 hearts, and 13 13 what? 13, we call them a flower, which is a crab, a diamond. We also have the other two. So each of these ones are 13. So what is the probability of getting a diamond? So what's the chance of picking a diamond? There are 13 diamonds and cards are 52. So to pick a diamond, it is 13 out of what? 52. All right, which is the same as 1/4. So this is a likelihood that you're going to pick a diamond out of a deck of those cards. In short, probability of any event is simply the number of events that are occurring divided by the sum total of those events. So we have come up with what is called an axiom. So this axiom of probability, number one, is that probability of an event A is simply going to be given by how many you have over a total event. This is very important. I always mention fruits. If we have fruits as follows, we have 3 bananas and 7 apples. What is the chance that we're going to pick a banana? It is 3 out of what? Out of the total number of fruits. How many fruits do we have? 10. But what is the chance that it will not be a banana? What is not is called a complement. So here we found 0.3, but what is the chance that it is not going to be a banana? It is 1 minus 0.3, which gives us what? 0.7. So a complement is simply what it is not. Any questions so far before I proceed? Okay. So we also go to another rule, because for you to understand Bayes' theorem, we need to break down these small rules. Okay. So probability must always range between what? 1 and 0. Anything above is not a probability. Or it should range between 0% and 100%. So of these ones, which one is not a probability? Negative 0.7. Why? Probability must never be less than 0. Which one or else is not a probability? 1.06, because it's greater than 1. This one is okay because it's less than 100%, but this one is not okay because it is what? It is more than 100%. This one, because it is negative. This one is okay, that's the maximum. This one is okay, but if we had 3/2, when you divide that, it is more than 1. So you need to know that probability should never be above 1. Okay. Now, probability has rules. These rules are called axioms. And these axioms we have already mentioned. Number 1 must range between 0 and 1. meaning you can't get a negative. All right. Number 2, the complement must always equate to 1 when we add the probabilities. So here we're going to have 1. Then number 3, we've just learned that to find the probability of A, it is simply the number of events A over the total number of sum total events. Number 4, probability, when you unite them, you're adding. This is the addition of probability. It is simply the probability of A plus the probability of B minus the intersection of A and B. So this simply means if you guys are taking 2 courses, A and B, and you're sharing QM, you add what A has plus what B has, you subtract the intersection. Intersection is what you both already have together to avoid duplication. This is an important rule in probability. Then we also have the axiom which says probability of A given B is simply, you take this one down first, probability of B, then you intersect the 2 letters starting with the first one which comes in the alphabet of A intersection B. Suppose it was swapped. If we had probability of B given A, which letter do we take down first? Probability of what? A. Then you intersect them starting with the letter which comes first in the alphabet, which is A intersection what? B. All right. So that is what we call the axioms of probability, and this is what we call Bayes' theorem. Now, Bayes' theorem is very important because Bayes' theorem brings to bear 5 key important formulas for intersection. So A intersection B, what did we say? What comes down here? Probability of B. What do we have on top? A intersection B. So if we had B given A, what comes down?
B.
What comes down?
Probability of A.
Then on top?
Probability of A intersect union B.
Then we'll cross multiply. So 1 times the intersection, it is A intersection B. And we multiply these two. A given B times what? Times the probability of B. That is formula number 1 for the intersection. As long as these 2 letters are the same, the base and the multiplicand, we get the intersection. Secondly, these 2 will cross multiply here. We get another intersection of A intersection B. A intersection B here will be what? B given A times what? B given A times what? Times A, as long as these are the same. All right? The other formula for A intersection B, if we're not given any Bayes' theorem, we just multiply the probability of A and the probability of B. Because intersection is the same as multiplication, or the word and simply stands for what? Multiplication, or at the same time, it stands for intersection. All right, the other one, A intersection B, you simply subtract A minus the intersection of A and B, but you put the complement on the other letter, which is B. Or if you want, you can say A intersection B, you subtract the intersection from B, the complement will be on the other letter, which is which other letter? A.
A.
Because here we have a B there. So these are the 5 important formulas that you need to know.
Okay.
So I said the complement of A is simply what? 1 minus A itself. What does it mean? If A is 30%, the complement is what? 70%. If A is 20%, the complement of A is 80%. If A is 40%, the remainder is a complement. Are we together?
Okay. Mm-hmm. Yes.
All right. So without much ado, I'll give you the simplified ways in which questions come. Suppose A is 0.2 and B is 0. Yes, Prudence?
Do you know when to use which formula? Because there are like almost 5 formulas.
That's a very
What's
good
the
question.
main difference?
When do you use which formula? So the question itself will direct you. So like this here, they're only A and B. Can somebody tell me how do we find the intersection of A and B? From these formulas, which formula can we use? We can't use this one because we don't have conditional probability. Neither can we use this one. But we can use this one directly because we're only given A and B. So whatever you're given will give you an idea. So here to find A intersection B, just multiply them because intersection means what? Multiply. So this is called theorem 1. But in an event where you're given A given B as 0.3, don't use theorem 1 because this theory surpasses them. Use a conditional probability. You say A given B times what is down there, which is what? B itself. Had we not, this part would have just multiplied the two of them, A times B, which is 0.1. But this one has power. Bayes' theorem has power. So it negates theorem 1. So that is where we now go. What is A given B? 0.3. What is the probability of B? 0.5. Then we get 0.15. Suppose we're actually given, instead of given this, we're actually given B given A as 0.3. Please, you need to take note of what is down there. In this case, we would simply multiply probability of B given A, not by B this time, but by what? This one here. Probability of what? A. Once you swap, you are gone because this is very important. B given A is not the same as A given B. These are different. However, A intersection B is the same as B intersection A. Same as 2 divided by 3 is not the same as 3 divided by 2. No. You need to be very careful. This is what kills people in Bayes' theorem. Now, suppose you can't remember what I've just mentioned. The surface is this. Given this, what you do is you're given this, given A given B is 0.3. The surface is use Bayes' theorem to expand this guy here. We know that A given B is equal to A intersection B divided by what? Divided by B, because B comes down. Since we're looking for this guy, you put what you already have. What is A given B? 0.3. What is the intersection? We don't know. What is our probability of B? Probability of B is 0.5. Then you cross multiply. 1 times the intersection is A intersection B. 0.3 times 0.5, 0.15. We still get the same answer that we got. So at that point, before I proceed, please lead us through. Suppose we're given the probability of X given Y as 0.4, probability of Y as 0.4, and probability of X as 0.2. Who can give us the probability of X intersection Y? I've given you 3 formulas. At least you can use any one of them. Who wants to try? How do we find the intersection of X and Y? Anyone? Come on. Yes, Prudence.
We use the second one. Okay.
We use what?
So we use the same formula that we had used earlier.
Give us, yes.
We would say, hello?
Yes, what's the formula?
So we say probability of X intersection Y, then over Y.
Okay, that's the formula for
Given Y.
probability of X given Y. Got what?
Intersection
Expanding the
Y.
Bayes theorem.
Yes.
X intersection Y over what?
Over probability of Y.
Probability of what?
Y.
Y, correct. Then you substitute what we've been given. What have we been given?
Yes. We've been given probability of X or given Y, which is 0.4. Then we've been given probability of Y, which is also 0.4.
We are looking for X intersection Y.
Yes.
Okay. So what do we do?
So we multiply 0.4 by 0.4, which is supposed to give us X intersection Y.
Excellent. Which is 0.16.
Yes.
Okay, then the union set. Then the union set, what is the union set for? X union Y. Who remembers the formula? It's probability of X plus probability of Y minus intersection of what? X intersection Y. What is the probability of X? 0.2. The probability of Y? 0.4. The intersection we found as 0.16. When we calculate that, we get 0.44. This is what we call our x union y. Then what is the complement of x? It is simply 1 minus the probability of x itself. So complement has a dash there. So since our x is 0.2, when we subtract it from 1, we get 0.8. So 0.8 is the complement of x. It's a brain work. Meaning what is the complement of y? The remainder from 1. So if our y is 0.4, the complement of y should be 0.6. Okay. So the complement is the remainder from 1. So now, suppose we are being asked to find the probability of x given y complement. How do we find it? Or we are asked to find the probability of x intersection y complement. I said whenever you have y complement, it is theorem what? Theorem 2. So meaning we need to understand the theorems. I said probability of A, if you want to use theorem 1, just add 2 intersections. A intersection B plus A intersection B, but the complement should be on the other letter, which is letter B. If here we had probability of A of B instead, just put A intersection B plus the probability of A intersection B, but the complement, since there's B there, should be on the other letter, which is A. So, and likewise, for us to have a complement on B, the letter should have been what? X, which was subject. So here we're going to say A intersection B. Here we're dealing with Y and X. So we're going to say X intersection Y, X intersection Y. But the complement is on the other letter. Since there's X there, the complement should be on Y. So this one is asking us to find X intersection Y. Do we have X? Yes. Do we have the intersection? Yes. Do we have this part? No. So we go find out. What is our X? 0.2. What is our intersection? We found it as 0.44. Okay. So X is 0.2. X was 0.2, and the intersection was 0.44. So you put 0.2, and the intersection here was 0.44. And you'll be asked to find the remainder. So Bayes' theorem is very important. You need to understand the axioms. Let's look at another question. Another principle before I look at the other question. So we've talked about the principle to say A given B is going to be equal to what? How do we expand this? A given B? A intersection B over what?
Over probability of B.
Over probability of B. Great. How about if you're given A given B complement? What will it be? A intersection B complement over probability of B complement. And what is the probability of B complement? 1 minus probability of what? B itself. And what is the probability of A intersection B complement? Since there's a complement here, our subject should be A. So we're going to say A is equal to what? Probability of A intersection B plus probability of A intersection B. But the complement, since the subject is A, will be on which letter? On B. Such that if you want to make this subject of formula, you simply say A minus intersection of A and B. If they're asking you to find the complement being on A, what would be the subject of formula? This one will actually be the probability of B minus what? The intersection of A and B. So it's all about manipulating to get your actual end formula. Then there are two conditions they'll ask you: mutual exclusiveness and independence. To be mutually exclusive is simply to have your intersection equals 0. If two events are mutually exclusive, it means A intersection B is equal to 0, or A intersection B is an empty set. This means we have mutually exclusive sets. They don't occur at the same time. There's nothing common. So A intersection B, they don't meet anywhere. If you are not compatible with a particular individual, you are like this. You don't meet anywhere. You have no common ground. You are mutually exclusive. They are disjoint sets. But if you have something in common, you have something in the intersection. A and B is not mutually exclusive. They're like this. You meet somewhere. You agree somewhere.
Okay.
Then A given B, they are independent. If A given B is equal to A, you maintain the top guy. To be independent, regardless of who's under there, you don't change the top guy there. Suppose we have B given A, just simply be B. That's what it means to be independent. Because the independence is not affected by whatever letter. Even if we put R or X, we still remain with B. All right.
Okay.
So to put this into perspective, we would have a question like this here. Number one, you are given probability of B given A as 0.4, probability of A as 0.5, probability of B as 0.4. You're being asked to find 10 things. Number one, what is the complement of B? What is the complement of B? So here we've been given the probability of B as 0.4. So who wants to try? The complement of B is 1 minus what? B itself. So 1 minus 0.4 will give you 0.6. That is a complement of B. Is that clear? Then the intersection of A intersection B. The shortcut is simply get this guy there, the Bayes theorem, and multiply it with the guy that is down, the denominator. So B given A, you multiply it by A. So our B given A is 0.4. multiplied by our A is 0.5. We get 0.2. Are you together?
Mhm.
As long as these two people are the same, you get an intersection. You can't multiply this one by B because here there is A. Then the union set is the most faithful formula because that one doesn't change. So A union B is simply the probability of A plus the probability of B. You subtract what? The intersection of A and B. So our A is 0.5, our B is 0.4. The intersection we just got as 0.2 is very important because once we get this one wrong, we also get the union set wrong. So here we get 0.7. Suppose they're asking us to find A given B. A given B is not the same as B given A. Yes, Prudence, you have a question?
Oh, I think you've answered. You've answered what I wanted to ask, because I wanted to find out, is B given A the same as A given B? Because on
That's
the
what we want
previous
to answer now.
question, yes.
So here, these are two different things. So B given A is not the same as A given B. So B given A is A intersection B over the denominator, which is B. So since we found our A intersection B as what? 0.2, and our B is 0.4. When you divide these two, you get our B, A given B as 0.5. Then next, they'll ask us, are they mutually exclusive? The condition for mutually exclusive is that they have nothing in common. A intersection B must be equal to 0. Now, is our A intersection B equal to 0? No. Actually, we found 0.2 as our intersection. So if these ones are not the same, we are essentially saying they're not mutually exclusive.
Mhm.
Secondly, are they independent? Let's try our rule for independence. A given B must be equal to the top guy, which is A.
Mhm.
Or B given A must be equal to what? The top guy, which is B. So step one, you set the rule, any of them. You may not need to do both of them. Then you compare. What is A given B? A given B is 0.5. Then here we have another A given, our A is what? 0.5. Are they the same? Yes. So you say they are independent. Wait a minute. Suppose we're comparing B given A. B given A is 0.4. What is our B? 0.4. Are they the same? Yes. So you say yes, the events are what? They are independent. If they're not the same, we say no, they're not what? Independent. By not being mutually exclusive, it doesn't automatically mean they are not independent at the same time. You need to test for those rules. They need to speak for themselves. Is that clear?
Okay.
Yes. So understanding these axioms is what will help you really understand these principles.
Mhm. Yeah.
Further, the examiner might want to ask, what is probability of A given B complement? Or maybe ask first, what is A intersection B complement? And what is B? This one in your mind, just know that whenever they're asking for this, here the subject of formula must be what? A minus intersection of A intersection B. Here, if they're asking this, here there must be what? B minus a normal intersection.
Mhm.
So what was our B and what was our A? Our A was 0.5
Mhm.
And our intersection was 0.2. Our B was 0.4, intersection is the same 0.2. So here 0.4, you're subtracting 0.2 from each one of them. So here we're going to get 0.3. Here we're going to get 0.2, such that if they'll ask us what is A given B complement, how do we find that? It is simply the intersection of A and B complement divided by what? B complement. We take them as they are appearing. The complement is on the B, so we write them as they are. A intersection B complement, the complement on B, we got 0.3 over, what was our B? Our B was 0.4. So the complement should be 1 minus 0.4. And 1 minus 0.4 is what makes us a complement. So this is 0.3 over 0.6, which gives us 0.5. Suppose we're asked to find complement on A given B. This one is going to be, who wants to try? We're going to have A complement intersection B divided by what? B complement or just B?
B.
Yeah, just B, because B doesn't have a complement. So A having a complement was 0.2. B as it is was 0.4. So what we get is 0.5. Lastly, suppose we're actually asked B given A complement. Who wants to try? How do we expand this? It will be what? A complement intersection what? B over
Over A complement.
A complement. Excellent. So what is A complement intersection B? 0.2. And what is a complement of A? We know that A was 0.5. So meaning what is a complement of A? It's also 0.5. Because when you subtract 1 minus 0.5, 0.5. So what we get? Get 0.4. Okay. So these axioms look very easy, but they're a handful. You will need to really put in your effort in order to understand.
Yeah. Can be confusing.
All right. So your homework will be in the revision kit, question number 9. Go to the group, or you can screen grab this. I sent this pamphlet on the group without solutions. You go to question number 9. I'll need this so that in the evening we'll look at the tree diagrams.
Okay.
All right.
Right.
I hope this has been insightful. So those of you who are not in the group, please get the class link or inbox me on this number 0977 620722. All right, so we have looked at Bayes' theorem with all the axioms surrounding. All right. A car has an insurer that offers two types of policies, home and car insurance. 70% of the customers have home insurance and 80% have car insurance. What is the probability that they do not have car insurance? So we're looking at the complement of C. Okay, so I think we end here. You try this. In one of my videos, I already did this question with you. Try it as much, think as much as possible, especially on part D. That's where I'll need much of the thinking.